There's George Lucas likes to say that history doesn't repeat, it rhymes. And there's a lot of truth to that. So when you look at our industry, the industry really came from the internet. And the internet, what the major thing there was that information used to be expensive to move. So it took time, effort, and money to move a book from Bob to Alice or to tell somebody something. Then this internet comes around, then suddenly emails here, we have the web browser, and magically you can just learn anything instantaneously. And the cost of moving information went to nothing. So because that became a thing, people started saying, well, what else can we teleport all around the world? We have all these siloed systems, for example, financial systems. It's really expensive and time consuming to move money around the world with remittances and wire transfers and these types of things. So for a long time, a lot of people were trying to create some sort of internet native digital currency that could represent value and just be teleported, just like email is teleported anywhere. And there were attempts as early as the late 1980s, the early 1990s, and there was pioneers like Hal Finney and Nick Szabo and Wei Dai and people like David Chaum. They even created companies in the 90s like DigiCash that were attempting to do this. But nobody had figured out a way to do it without involving some trusted third party, some central company that acts as a settlement and clearinghouse. And that's really not desirable in the age of the internet. Then around 2013, Bitcoin got real. It reached $1 billion for the first time ever. The Cypriot Act crisis, where a government was just taking money out of people's bank accounts, it got people deeply concerned. Entrepreneurs started coming in, like Wentz Casares and others, and Silicon Valley showed up and legitimate exchanges were created. I call it the accidental project. And the reason being is that nobody intended for Ethereum to really exist at the scale that it exists today and had illusions that we were somehow going to be this $200 billion Leviathan that brings in an industry. It was more of a project of frustration. It's no coincidence that the Ethereum founders, all of them had either been building altcoins or building overlay protocols. And because these things were trying to compensate for things that were missing in Bitcoin. And so the point of Ethereum was to basically be a proof of concept to show how to build a native smart contracting system that just works and it actually people can build real stuff on it. The hope was just to basically encourage the space to understand about programmability and its necessity. From my view, I said, well, there's a lot of things I'm very interested in. I cared a lot about economic inclusion. I care a lot about economic identity. And I said, well, if this technology is going to be any good, it should be the financial operating system for the world. And Bill Gates and the shepherd from Senegal has the same access and privilege and rights in the system. We've never had that in human history. Well, to do that, I need protocols to do that. And I can't do that with Bitcoin, but Bitcoin is moving in the right direction. So my thought process was, if we built something like this, if it became successful, it will either grow to a point where we can start building that type of stuff, and then I can focus on that, or it will encourage the Bitcoin community to upgrade Bitcoin to do this, and then I can build on Bitcoin and do it. So I didn't really know which one was going to get there, but I knew that this was another step in the right direction. The problem with Ethereum is that it is really truly a proof of concept. And the first person to agree about that is Vitalik, because he's building Ethereum 2. You don't go build the sequel if the original is okay. And there are really three classes of problems. And I term this the third generation problems. And this is where we're currently at as an industry. And many people are chasing them in their own ways. First, there's scale. And that's a super easy one to understand. So in a distributed system, you'd like a situation that as you add people, the quality of experience and the availability of resources and operating cost stays the same or it gets better. You don't want a situation where there's a scarcity phenomena that as you add people, you get less and less for everyone. The easiest way of understanding that is kind of thinking like, imagine a dinner where you add people around a table, but you have the same amount of food. Everybody gets less on their plate. You'd ideally like a potluck where people come and as they show up, they bring food with them. So there's enough food to feed everybody regardless of the size of the party. And we have protocols like this. For example, Bittorrent is one of the greatest examples where the more people downloading a movie on Bittorrent, the faster you get it, as opposed to the slower. And that's opposite of most web systems where the more people using something, if you're at a surge hour, the website gets slower and harder to access. So that's the first property, is that we don't have that in the cryptocurrency space. And this is why Ethereum fees are so expensive and why Bitcoin gets clogged. And why you can't really do things when you start talking about millions to billions of users. Problem. Second, there's over 8,000 cryptocurrencies now. Holy hell. And there's tons of legacy financial systems floating around. And so how the heck do all these things talk to each other? Imagine Wi-Fi, where your Wi-Fi only works with the manufacturer of your phone. So your Apple phone can only talk to an Apple router. Your Samsung phone can only talk to a Samsung router. It'd be a mess. But we don't have that. We have perhaps the first truly interoperable protocol in all of humanity. You can be in North Korea, South Korea, Iran, Israel, Russia, China, America, in Germany. And despite the fact these countries collectively will never agree on anything common, your phone probably can connect to the hotel Wi-Fi network in all of them. So what is the Wi-Fi moment for our industry? How do you move assets? How do you move identity, people, value, information between systems? And so there's a huge demand for interoperability if these things are truly to be useful, or else what will happen is you'll have 800 fragmented standards and the world won't consolidate. And then finally, you have this meta problem of governance. And I call this the who pays and who decides, or the sustainability problem. So Bitcoin, the reason why it's not competitive is because it can't evolve. But even if they want to add smart contract support or side chains or more scalable protocols, it's chaos. It's damn near impossible to upgrade that protocol, and because there's no governance layer. How do you govern a system without rulers? Normally we think there's a CEO, there's a company, there's Microsoft to Windows, there's Apple to the iPhone, there's Google to Android. Even if these are federated projects like Linux, there's still some ruling class of powerful companies or powerful individuals that stand behind the project. They kind of act as beneficent dictators or the prophets who shall say what the future needs to be and kind of push people in that direction. With cryptocurrencies, we're saying no one's in charge. There's no leader, there's no CEO, there's no president, there's no powerful company that gets to decide. So the problem is in the absence of that, you have two models. Either you can somehow self-assemble a completely decentralized government and figure out a way to converge to controversial decisions, or you have anarchy and chaos and things slow down as you add people. So just like scalability, as you add people to the system slows down under the current designs. As you add people to the system, their innovation rate slows down. It becomes more and more difficult for us to actually see things come better. The internet is a great example of that. Look how long it's taken to get IPv6 compliance. Look how long it's taken us to get things that everybody agrees is a universally good idea. Yet it takes 20, 30 years for the internet to upgrade because it doesn't have the right type of governance layer. So everything grinds to a halt, and it's very difficult to do system scale upgrades. Well, these are financial protocols, not just communication protocols. They have identity, they have value, they have all these things. And if you're really going to be competitive with the legacy financial system, you need the ability to upgrade with some predictability. And even if it takes years, it's a process that we know will eventually converge and get done without creating a Bitcoin Cash or a Bitcoin SV or an Ethereum Classic or any of these governance failures that we see inside the system. So that's the third problem, is the sustainability problem. And a corollary to that problem is the problem of who pays. A lot of this innovation is horrendously expensive. We as a company pay tens of millions of dollars in engineering and science fees every year just to maintain our people. But then collectively, there are probably $100, $200 million of money that our industry is spending on engineering and R&D budgets just to write and come up with new protocols. And as our industry grows in size and scale, that's going to become billions of dollars. So how does a cryptocurrency pay for its own growth? You need some form of a treasury system for this. You need some sort of financing model that allows it to pay not just today's bills, but bills 20 years from now, bills 30 years from now, or else you'll have the golden rule. He who has the gold makes the rules. So if you add these three things together, sustainability, scalability, and interoperability, I view that as kind of the third generation problem of cryptocurrencies. You keep all the old stuff, you keep the programmability, you keep the instantaneously being able to teleport value, you keep the decentralization. You have to do all of that, but now you have to do it at a scale of billions of people. Now you have to do it where it can talk to everything else. And now you have to do it where it has the ability to govern itself and pay for its own bills. And the first person to solve that is probably going to realize the vision that Satoshi started with, and then the cypherpunks were started with in the 1980s, which is truly a global scale financial operating system.
So tell us a little bit about the genesis of the project and what you were particularly trying to solve for with relation to scale, interoperability, and governance?
Yeah, so first off, we didn't know how to build it when we started it, but we knew the process that would tell us how to build it. And that's exactly the way you should start. And so the first thing we did is we said, let's just go buy up all the academic talent. So let's go hire a bunch of scientists. Let's set up a lot of research centers at different universities, and let's read everybody's paper, everybody's code, and get a really good sense of how all this stuff works. We ended up writing almost 100 papers. A lot of them went through peer review at computer science conferences, which is the gold standard of the computer science field. And basically what these papers did is they fixed a lot of broken windows, and they kind of mapped out the science of our entire space and what you can and can't do. So we had to figure out a better engine. Proof of work, for example, it's like the steam engine in the Industrial Revolution. It proved that mechanical work is better than human labor. But if we had stayed on the steam engine, we'd cut all the trees in Europe down, and it would be an ecological catastrophe, and eventually it's self-destructive. And it took 6 years and lots of papers and lots of hard work to basically figure out, yes, it does work, and here's how to do it, and here's how to do it at scale. And we did this in every category, from the ledger rules, the way the network was designed, how programming languages work, and so forth. And we brought in usually the top guy in the world or the top person in the world, and we built out a beautiful framework of science. But science is not a product. So in 2017, we had a sea change in the project where we said, okay, it's fun being researchers and writing papers. I love reading them. I love writing them. It's a good thing. But we actually need to write code. We actually need to build a product, release it into the world, and build an ecosystem and community. So then we asked, well, how do we do that? So we had to find like a programming language and a programming paradigm that would give us the ability to follow the science, but also be a real product that people can use, and it's useful and it's performant and so forth. So we found a great programming language. It was called Haskell, and we followed a mechanism called formal methods, and we pulled all that together. And there was a bit of rough edges there because Haskell wasn't quite ready for an industrial product of this scale. So we actually had to improve the programming language itself, and we set up the Haskell Foundation with others. We made a lot of contributions for cross-platform compatibility, like how to get it to work on Windows and path to getting on mobile devices and so forth, getting it into the browser. It was an enormous engineering effort. It was like a Manhattan Project worth of engineering because we had to implement all this difficult science. We had to do new crypto, but then we had to also make the tools better because the tools weren't ready for prime time for what we were trying to do. And we had launched Cardano in September of 2017. We went through a series of massive upgrades last year, and we're doing now a series of massive upgrades this year. And we've built a community almost 1 million people strong. All of our social metrics are super strong. They keep growing every day. And there's a lot of use and utility that's coming down the pipe. We built an office in Ethiopia. We actually went and had people live in the country and train developers there. And we started business development actually all the way back in 2017. And we spent 4 years just building and learning. We started building people in Mongolia, in the country of Georgia, and a lot of jurisdictions. And what's great is we'll give them identities, we'll give them settlement systems, payment systems, eventually voting systems, property registration systems. So we're living the dream. And there's a bit of an inevitability behind what we're doing because there's such a strong appetite for these things. And the way we constructed Cardano's underlying protocol, we have it all. We have a way to fund it indefinitely because of the treasury components of it. We have a decentralized brain because we embedded it within the universities. So there's all these new graduate students and postdocs that are always coming, and they're always able to keep innovating. We have the right programming model that it's built on granite. So there's no bugs or security flaws or existential protocol things that are going to blow up in your face and kill you. And we have the right marketplaces where there's a lot of young, very passionate people that want change. Like Ethiopia, 70% of the country's at or under the age of 30. Most are digital.
What Ethereum is, they understand it's a digital store of value, kind of a metaphor for gold. They understand smart contracts are the ability to execute code on a blockchain. What is it exactly that Cardano does for people who are not eyeball deep in the digital asset space?
Yeah, so basically it's just a collection of protocols and technology that allows you to transform, store, and manage value, identity, and governance. So if you have an instrument of value, that could be a stock, a bond, a commodity, a token, an NFT, like a Pokemon card. It doesn't really matter. You need some place to store it, transmit it. You need some place to build contractual relationships around it. Like I'll give you my Pokemon cards if you mow my lawn, that type of a deal. Okay. Identity is who are you? Normally, we take that for granted. Oh, I have passport, I have driver's license, but you have credit score. Is it a fair credit score? And so there's a lot of these things that don't make a lot of sense in how identity is brokered and handled in our world, but in the developing world, it's non-existent in many places. There's tons of people there that are brilliant, that are honest, that are very hardworking, and they are completely shut off from the global economy because there's no way to assess whether that counterparty is reputable, trustworthy. Like, for example, microfinance. Let's say some guy runs a farm and says, I want $200, $300 for a loan for fertilizer. And if I do this, I can upgrade my farm, get much better yields, and I'll make windfall money, and I'll be able to pay that back. He said, great, 85% interest. He said, oh God, that's usurious. It was, well, how do I trust the counterparty? How do I know you're actually going to pay me back? The default rate may be high, may be low. There's no credit systems in a lot of these places. Yeah. So identity is a huge problem. And that's why 3 billion people are under or unbanked in the entire world. And that's why remittances are 15%. That's why microfinance is so expensive. That's why we don't have good insurance markets in these places to protect people on the downside. So we need an engine for identity. And then finally, for governance, how do you govern things? You have to broker trust relationships between these entities to be able to move subscribers and data and other such things between networks, because we travel. If I land in Heathrow, I'd like, when I turn my phone on, for my phone to work. And it shouldn't take 500 lawyers and billions of dollars to make such an arrangement work. It should be seamless from one system to another system. And that's where there's Fortune 500. What about medical records? I've been 52 countries in the last few years, and I'm thinking, gosh, what if I got in a car accident in Tanzania and I'm unconscious? And there's a Tanzanian doctor calls my doctor in Colorado and says, hey, Charles is unconscious, but I need all of his medical records because I'm trying to treat him. No, trust me, I'm real and legit. He can't talk to you, though, because he's unconscious. How does he get my medical records? And that's the point of these protocols, is that there's a million of these problems, whether it be the adulteration of drugs, like Mongolia, a third of all the medicine in that country is in some way bad, could be expired or mislabeled or counterfeit. So if you're trying to take an antibiotic, you have 1-3 chance of getting a bad pill. That's a problem. And the point of our industry, this technology, is to say it's a Swiss Army knife of protocols where you can build applications on top of it that handle that brokering of value, identity, and governance so that you can solve real problems.